So what we should see is some of these particles avoiding each other a little bit and trying to go towards their intended destination. We should also see some momentum on the particles. So hopefully along the line where we're spawning these particles, we will see them kind of fan out from that line and then kind of curve down towards the location where they should be. I gotta love all these really horrible MS Paint drawings that I'm accumulating for this. It's just like, you know, in the movies you see like the crazy dude who's got all sorts of stuff on the wall with pins and arrows, and he's like, "Oh my God, they're gonna assassinate the president, and this guy is actually an alien." They'd come into my basement and they'd be like, "What the hell was this guy working on? He's got like all these inverted axes and like all these like data things, and then like some stuff about Australia on the wall. Like, this guy's insane. He locked himself with his basement with all these guns, and he's crazy. He talks to a box that's connected to this magical universe online. This guy was not right in the head." The guy thought Z was up. What a moron. Everybody knows Y is up. So yeah, we can see some of this where you know, these particles spawned off and they're kind of coming off and around from here. And you know, we can see how this rock kind of blocked some of this stuff as it came across, and it's got a shadow. Some particles, it looks like, I don't think they're... We're going to need to have them actually... Will they avoid the shore? Is that a thing? I think so. Let's give them a little bit more weight towards avoidance. Let's give them like a 2 for the avoid weight, and let's see what happens with that. Should sell them, make a showroom. Yeah, we'll have all the memorabilia, and we'll sell it on eBay for like $2. Yeah, one of the things I read this weekend was that article on the video game, the PC game Gigantic, from like, I think it was Motiga or whatever, and how a bunch of game devs, like, they ran out of money, and then everybody basically showed back up to work even though they weren't getting paid, and then now they've like shipped the game and it's not doing well. And it's like some big sob story about like, oh man, these guys are so dedicated and they've done all this work. And I was just like, Jesus Christ, like, if I was a manager and like I ran out of money and like everybody showed back up to work, I mean, it's not like game development pays everybody in like Cadillacs or something. Like, you're not making like $2 million a day, and a lot of these people have like families, and a lot of people are real like a lot of people in the game industry are very passionate about games. That's why they get into the game industry, right? And I'm like, man, if I was in charge of a studio, we ran out of money, and people showed back up to work, I would be like, dude, okay, I'm sorry. Like, this is where you need to like think of your family. All right, so this is with an overweight for avoidance, and what's happening is we're avoiding things too much. Like we're like avoiding the everyone's like going to the shore. They're like, get away. Making money would be nice for a change. It's true. But if I was that manager, a lot of people, especially right out of college in industries, they don't really know their worth in the industry, and they can get taken advantage of really easily by people who are like, it's somebody's first job, so they don't have a good barometer on like self-respect and like what should happen in a workplace, so they get easily manipulated by managers who for reasons maybe they don't really realize how manipulative they are. They can just crush people. As I said, making any money would be nice. This is true. But it's kind of like at the end of the day, making games is a business. I mean, you can make the argument that making games is not a business; it's a passion project. But when you get to the level of businesses where you have like 30 to 60 people working on a game, that is definitely a business, right? You need to get healthcare for your employees. Like this isn't just you screwing around with your friends making a game and working on like a boat on the weekend or something. This is people's lives matter. This affects not only their people but their kids, like if they can go to college, a lot of stuff that actually matters. So if I was like the manager of that company, I would have shut it down. I'd be like, dude, you guys need to go home. Like, I will help you find jobs, but for the love of God, do not like bank on a game making a bunch of money when we can't even afford to hire all the people we need. I mean, you're obviously not going to be able to pay for the marketing necessary to make money off the game if you can't even afford to make payroll. And games also are hit and miss. Like, you can make the best game in the world and nobody cares. And it'd be like Psyonix. They ship Rocket League. You think they expected Rocket League to be the biggest damn game ever? When it released like it was? No, not at all. They called me up at midnight. They're like, Kirk, holy shit, we need help on our servers. And I was like, my advice to them was, how old are your engineers? And they're like, well, we're all like over 30. And I'm like, well, that sucks because you guys are going to be up for the next 2 weeks straight. What you need to do is just knuckle down and get it done. I can't help you. And they already shipped basically Rocket League years ago. This is pretty much just the updated game. And somehow it's stuck. So you're always banking on chance, and you as a manager have to build that into your psyche and have some damn ethics. So when I see articles like that, it's a sob story about people getting angry, about like, we should support these devs. I'm just like, Jesus Christ, we should be like prosecuting this guy for having illegal labor practices. like that, like that's what should be happening right now. We should be liquidating that company and giving it to the goddamn employees. you know, to actually make their payroll. Anyway, so we have our avoidance radius. So what's the problem? It's our particles are, if we have our avoidance radius, exploitation is widespread. It very much is. So what exactly is going on here is we want, if we change the acceleration of our objects to be much lower, what's going to happen there? Let's just say m acceleration equals, you know, like 0.1 f. Yeah, exploitation is widespread. Like I think one of my articles about that was this one article where I think it was called "How I Fired Myself." It was about this guy who was working at Click Nation in Sacramento, and he was like a junior engineer, and their standard practice was they would update the database in production live. You can't be an intern anymore. Yeah. Yeah, the internship, I mean, all that is kind of, I would be fine with, you know, as long as people are paid for their internship. They don't have to be paid much, but they got to be paid something. You know, like free internships are kind of bullshit. Unless they come with a contract of like, you know, an apprenticeship, like we will hire you, unless like, you know, you turn out to be like some racist scumbag or something. Alright, so our acceleration is slow. Let's see what happens with that. It's starting to look much more like what we want. Like, this is definitely starting to do things. That's been one of, that's like everybody's major problem. It's like getting experience out of college is just such a gigantic pain in the ass. So I think the avoidance needs to be lower. The avoidance weight needs to be lower. I like that the acceleration being lower actually worked very well for this thing. Well, actually, I think these things like avoided each other and then they couldn't stop avoiding each other. So it's like the avoidance thing needs to be like exponential or something. So how would we make this exponential avoidance? Alright, so if we have the direction, we have the magnitude squared, why don't we just divide this direction? So we're gonna divide the direction by dir dot size squared. Let's increase the goal weight. The avoid radius is 3, so we're checking pixels around us like that. It should be good. Let's make the depth radius something much larger so we could sink these things in there. You're just gonna be complaining now. I'm, I'm, I'm rubbing off on you. Everything is like that, though. Yeah, that's one of the things about breaking into industries or whatever. Like after college, like I couldn't get a job. The only reason I got a job was I broke into a party I wasn't supposed to be at and complained to people, and they were dumb enough to hire me. But after college, like a lot of my friends, like pretty much, even though they're all fully qualified, like in our college was specifically designed to give you gameplay programming experience. Like you made 4 projects over years with people. Like no other college does that, anywhere except for like some stuff with like Carnegie Mellon and stuff that has equivalent actual project stuff. And even that's not 4 years. I think that's just 1 year. And pretty much everybody, their first jobs were contract positions at Microsoft or something they didn't want to do. Now, I don't like what's happening here with this, like, these accelerations are not working. Like, we're getting, this sort of effect here, with these flow fields where stuff will move around this rock properly and all that. But what we're not seeing is, these things need to be going towards that value. Like, they need to be weighted more strongly towards it for some reason, and they're trying to like avoid the pixels here, but they should be going towards that. It's normal to go 1 year without anything. That's just damaging to a person on a psychological level. So try to think, what can we do about this? We can reduce the avoidance radius. Well, we can just do the we can increase the goal weight. We'll see how that works. This looks like ocean glow. Well, we're getting there. Like a lot of this stuff is, we can, and this is just like one little pattern here. We can maybe give ourselves a few hints, right? Like we can also put in objects that we want. Like we could maybe build a little path for our water to go around and then do the particle thing as well. So if we don't necessarily have to stick 100% to our algorithm. We can kind of do this particle discovery thing, and it might just be one part of the water flow field stuff. So maybe we actually want to draw a line ourselves or something like that, or place some objects in the water to kind of shape it. I don't know. We'll see. Alright, so our goal weight is higher. And these things are going to avoid each other. And that's kind of the problem. Is they're avoiding each other and they're just getting screwed somehow. Oh, interesting. Alright, I think I have a solution for these particles. If I kill them after a certain amount of time, a certain number of ticks, it'll work. So I can decrease the weight for this thing, and if I delete them, it'll definitely work. Alright, so that's what we're going to do. We're going to put a life on these things. So what sort of life do we want? So let's do this. Let's say particle.emLife equals, let's do a random value. Let's say the particle life range should be between 100 and 200. Alright, so we're going to say if emLife is less than emTicks, return false. And let's change the goal weight back to 1. And we'll see what it looks like. And we're just kind of playing around with this sort of calculation to see how these particles act. So we've given them a weight of like 100. I mean, a life of 100. So you have to also kind of understand how these particles are working here is these particles aren't moving. So even though we have a high concentration of particles actually here, inside of the flow field, they're not doing anything. So they're going to be like no movement water, even though there's stuff here. These values are moving out here, so they would actually have movement. So it's not about the particle concentration, it's more about how these particles are moving just in general. So what we're wanting to see is if particles are actually, forming these shadows and stuff like that. That's much more important than any of the rest of this. And obviously we have a bug here. That bug is going to be that we are not. Yeah, we had fixed this in the array version of this, but we didn't fix it for this guy, which is we have remove node here, but we don't have this. Yeah, we need to clear our collisions here, and I think the lifetime needs to be a lot lower for these values. You know, we should have like 25 to 100, I think, ticks for the particles. And we may need to increase the random particles to kind of fill in the flow field itself. So it's starting to actually look like we're gonna be successful with this sort of thing. I'm not, because these things are blue down here, they're moving fast. So like if this flow field was true, what would happen is this water would be moving, and then it like, you know, it moves real quick over to here. So what you would see in a flow field is like if a little fat sack was floating along, he'd go, whoa, and like over here, and then he'd probably come in here, and then get slung up against the shore. Which, I mean, you know, let's be honest, if a waterfall was like crashing into a place like this and there was like a little sinkhole right here, the water would be just like smashing against these rocks and going all over the place, right? So, I mean, it's not completely unrealistic. And, you know, these particles here look like they would kind of be moving towards it. So I think we need a higher lifetime for a particle in order to get that working properly. We also need to not spawn particles that are too close to that the death zone. All right, so if x minus, yeah, let's see, f math of absolute value of x minus dest x is less than 10, or fmath absolute value of y minus dest y is less than 10. Let's just return. Think that would work in a way already? Yeah, it's getting there. I mean, it definitely would have, you know, some motion, and you would be able to see it. Like even there, there'd be some, you know, we'd have our shore blending and everything else, and that would be basically like a whole bunch of turbulence right there on shore, and a whole bunch of turbulence and stuff like that around, you know, this black hole in the middle of the lake. You know, and that turbulence would be all around it. Like, you know, yeah, it would look real weird. But you could definitely make the material use that information and do some interesting stuff. Yeah, it wouldn't look like a whirlpool, right? It's not like all swirling around with a huge bunch of momentum. It'd be kind of this weird crashing around thing. It'd kind of be like a kind of a it crashes and can't go down, so it's kind of getting sucked in from behind and stuff like that. So it wouldn't spiral. It's interesting, as you continue this simulation, it starts to kind of even out a bit with the lifetime of the particles. Actually, it looks like looking okay. I think we need more random particles. And we could add a little bit more shore avoidance. Yeah, shore avoidance would be really cool, I think, actually. Okay, so we need to do that too. So let's up the random particle number. Random particles per frame is going to be the width times 0.5. Let's change that to 0.1. Let's double it. So this will be like, for a 512 app, this is 51. Alright, so do we have the information that we need? We've got the flow field here inside the tick as well, so we're going to, so we float shore weight, that's 1.0f, and we're going to want a shore avoidance. Alright, so we need to actually look at all the stuff around us. So this space occupied is looking up our path stuff here in our path lookup. It's flow field cached height index. So let's see, like, let's do bool flow path map. Space is shore in 32x and 32y. Calculated flow field. Here we go. Okay, space is shore. Now, I think we can actually just get the distance to the shore, because we already have that, don't we? Like, we've got our cached distances, so like, let's just get distance to shore. But if we have the distance to shore, we don't know where to go. We have to check if it's shore. Hello, G Pudding. What am I doing? It is a good question. I have no clue. I have no clue what I'm doing. I'm lost. What I'm trying to do is I'm trying to create a flow field for the water in our game. So basically, if we start on this X and we are going to this location here with our water flow, you know, we want like the water to, you know, kind of look like that, you know, flow around a rock maybe, stuff like this. And the way we're doing that is we're creating particles. Like we used a pathfinding algorithm to find this basic path here. We're spawning particles along this path, and we're having them avoid each other and then try to avoid the shore and make their way to their destination. So the particles will get spawned off and they will avoid each other, avoid the shore, but eventually they'll find their way over here, and the particles last a certain amount of time before they disappear, and if they get to the destination, they will suicide themselves. So, allowing more space for other particles to come over. So that's kind of what we're working on right now. It's a slow process, and we're writing that information to a texture so that we can then reference that inside of an Unreal material. So F vector 2D pause. And we're writing all these functions and all that to help us out. So pause.x, pause.y. So this is going to go on the flow path map. And this is all part of a greater effort to just get all the information together so we can make a water material in the game. Alright, so our shore avoidance, what are we going to do for this? Let's see. I guess we should use the same avoidance. We could just use the same avoidance stuff that we had here. Just do this like shore avoid. So if map dot space is shore. Let's see, test pause, flow field, then our I'm just gonna kind of cut out some of the normalization here. So it'll be shore void plus equal this direction. Numbers. Yeah, we're gonna need another one for void num and shore num. We don't need to actually average those vectors, it doesn't look like, so the avoid num just doesn't matter. So it's just avoid vector dot normalize. Yeah, we should definitely do something like this. So we can get rid of some of these divides. So it's just dir divided by size squared. We'll do that, shore void, shore weight. That should work. So we should avoid the shore. Hooray. I guess the other way we could avoid the shore is not by testing the shore around us, is by looking at the distance to shore around us, and if we're going to something that's closer to shore than where we are, we could like add an avoidance vector to that. Excuse me. The other thing is we might optimize the shore avoidance vector by, instead of having it check in a square, we could have it check in a straight line or something like that. Because our shores are probably going to be if we're flowing towards something, if we checked in a diagonal line, we'd probably avoid stuff real well. Because if we're checking this square, yeah, I think I'm going to change the floor avoidance here real quick. So we're going to do like int32 floor avoid check distance, and let's set it to like 20 or something like that. Yeah, and let's just do I for this one. I is less than or equal to floor void distance plus plus I. We're going to get this shore avoidance here. We're going to get our test position, which is going to be this test pos, and what we're going to do is we're going to test two positions. So we're going to set this pos equal to this, and we're going to go in two exits. We're going to go from top left to bottom right. So it's going to be test pos.x plus equals I, and y is plus equal I. And we'll test it, and we'll add to our shore avoid. And then we will test again with a minus equals. I mean, wait, no. Is this what we need? So this will be like negative x and positive y, and then that'll go down and all that. And this one's going to be negative x, and then it's going to come down. Okay, so that should form an x for us. And let's have our shore avoid weight actually be higher than our goal weight. Let's just see what it does. I'm not sure. So we added more random particles, and we added a strong shore avoidance X test. So we should see as a particle moves towards shore, it could crash straight into it, but it won't. It'll tend to avoid it with these sensors that are off on the diagonals. So if it's moving towards a rock and the rock is by it, it's going to kind of skirt around the rock. We could probably optimize that by only having us avoid stuff if we're moving toward it, but that's not really a big deal. Alright, well, we crashed. We're just kind of playing with this until we get something that we like the looks of. So we're not really expecting to just, do a whole bunch of work and just like, oh, there's the answer. We finished writing all the code, and then we just run it and have it work. We're experimenting. So we're not trying to rush anywhere. Because I have never made like water flow field stuff and all that ever, and so we're just kind of seeing what works. Oops, that was the wrong button. I called the construct static flow field button, but I clicked it like a whole bunch of times. That's not what I would have expected. I would not expect a whole bunch of water to just kind of hang around in there, right? I expect it to be repelled, not be hanging out next to it. did we screw up our avoidance check? Well, maybe we should just do something a little bit different. Maybe we should switch it up with a square check. Just do it that way. Yeah, kind of a bigger square check, that's true. And I really want to see this thing actually affect the object a little bit more, the particle. So, you know, I want this stuff to avoid those rocks. Why do I have gloves on? I have gloves on for many reasons. Hello, Quentin Capino. Hope you're doing well today. I am doing well. I have gloves on because long story short, after college I played a whole bunch of MMOs, and you know, you've seen that episode of South Park with the dude who has no life. I saw that episode, and unlike a lot of people, I saw a genius. I saw a person who wore gloves on their hand to prevent the mark of the master race from forming on your palm. So I went and got some good bike gloves and etc. And I was like, I'm gonna try these out, and pretty much since then that's what I do. Is I've got these gloves on and they help me out. Yeah, it's one of those things. It's stupid, but it does actually help out with you know, keeping your hands together. One of the things, you know, repetitive stress injuries can happen much more easily if your hands are cold and stuff like that. I'm not seeing these particles avoid this thing too well. Like, they're getting... Like, they should be moving away from this. You know, they should never be able to actually approach this. So what is happening here? Shore void plus equal dir. Space is short. Well, let's just put a breakpoint in there and see if we actually are adding any vectors here. You know, like maybe we're getting a 0. the ultimate love question. Yeah, it's just one of those. Alright, what is the test position? Alright, shore void direction. Yeah, that's going to get optimized out. So that it is getting triggered, it is working, supposedly. Alright, well, what if our acceleration is higher? Right? Like, what if the acceleration can affect our object? Maybe we're getting it so that the object can't actually change its direction, so it just kind of slams into the shore, and then it's like close to the shore, and it can't do anything. It just kind of sits there next to the shore, trying to get away from it, but it can't, and it tries to move a little bit farther, and then it's no longer too close to the shore. And we should definitely have this size distance squared here. So this is kind of similar to a game I made my sophomore year of college, which had a whole bunch of spaceships that were flying around, and the AI in that would avoid the asteroids by like flying around them and stuff. And I basically had them like cast, rays out and like find stuff, and then they would choose to go like left or right around like the asteroid. But that AI was a lot more complex than I'm going to make this thing. Because I don't think I need all of that. I think we can just kind of throw enough particles at this in like a static computation that it's not going to be too big of a deal. And the globes give you something to play with when you're compiling code, right? So you don't just like get distracted by the internet. I always get distracted by the internet. Yeah, the internet is full of distractions. Alright, so this is the sort of stuff I'm looking for. Like that's information that's going to cause, some turbulence around a rock, which is pretty cool. And we got this avoidance stuff here, like these things are kind of, moving around it. And the thing is, on our actual height map, there's a gap in this rock. There's this rock has got, it's a really crappy rock. Like if you look under the shore, like it's not actually like ground. It's like they're floating rocks. So I should probably just fix that real quick.